So the second part we need to get this unknown molarity is we need to figure out the moles of hydrochloric acid. The moles of hydrochloric acid are related to the amount of sodium hydroxide that it takes to reach the equivalence point. So we're going to set this equal to 13.17 milliliters of sodium hydroxide. We also have the known concentration of sodium hydroxide, 0.150 molar sodium hydroxide. Remember, molarity is a conversion factor. 0.150 capital M means 0.150 moles of sodium hydroxide per 1 liter of sodium hydroxide solution. So there really are two units when you see a capital M. That tells you it's going to be a conversion factor. And we need that conversion factor because we want to turn milliliters of sodium hydroxide into milliliters and eventually into moles of, we just want to turn milliliters of sodium hydroxide, we want to get moles of hydrochloric acid. So if we can turn our milliliters of sodium hydroxide into liters, then we can use our molarity conversion factor. We know that there are 1,000 milliliters in a liter of sodium hydroxide solution. And now we can use our molarity. 1 liter of this sodium hydroxide solution has 0.150 moles sodium hydroxide. We're almost where we want to be. We want to turn moles of sodium hydroxide into moles of hydrochloric acid. What relates those two things together is the balanced chemical equation, which in this case is a 1-to-1 mole-to-mole ratio. So that tells you 1 mole of sodium hydroxide reacts with 1 mole hydrochloric acid. The moles of hydrochloric acid, when you multiply this out, gives you 1.9755 times 10 to the negative 3 moles of hydrochloric acid. That's the numerator that we need for this problem. So now we can put everything together and get our final answer, capital M, 1.9755 times 10 to the negative 3 moles, divided by the liters of solution, which is 0.025 liters. And our molarity is 0.079 molar as our final answer.